Here we are going to learn designing circuit according to Boolean expression, right? Once we derive the expression, accordingly we can design the logic gate. Now see here this example. To fulfill a certain task, following condition need to be met. X need to be true always. X need to be true always. Let's say always on or whatever the condition, always need to be true, not false. Either the Y or Z need to be true. That means both no need to be true. One, either Y or Z. So write down the Boolean expression, right? Then X, right? X is always must know. Then X and Y or Z. It's very clear, right? X is always need to be true, X or Y. Then both condition. Here X always need to be true, and what is the other condition? Y or Z. Now this is the Boolean expression. Now to draw the circuit, it's very simple, right? Now from here only we need to divide. For example, let's say the output is Q. Q is equal, right, X and Y or Z. Then one branch X should come, because from here only we are starting. Q is equal, first it is meeting the X. That's how we need to follow the sequence, right? From output Q is equal, first we are meeting the X. Then you have to see any O AND is there. Now next to that AND. Then from the other branch this should come. Very simple. That means for AND gate there are two branches. One branch should represent X, the other branch should represent Y or Z. Here see, X, Q is equal X, one branch should represent X, right? Clear? Directly we are fixing to the AND gate. The other branch, here we should get Y or Z. Very simple. Then you have to see, to get Y or Z, right? To input Y or Z, we need to get the result here, no? Y or Z. To get Y or Z, you know O mean always O gate, no? So you put the O gate and feed Y and Z. So this is the logic circuit. It's very simple. If you understand the theory, any complicated Boolean expression, you can design the logic gate. Now see this one. Consider the Boolean expression D is equal A. First of all, D is equal A and B or C, right? Now here the no bracket here, straight away telling D is equal A and B. So that means one input should be A and B, O C bar, right? O C bar. Then here the O mean the O gate. Now here this is inside the bracket, no? This is inside the bracket, no? So therefore we are taking this as one component. Now here A and B, actually bracket should come here after A and B. After that only we are getting O. So then you see D, one branch A and B, the other branch C bar. Here A and B. So we need to input A and B here. Then definitely we need an AND gate here. Then AB. C, you can place a NOT gate. Then you will be getting C bar. Now D is equal A and B or C bar. Write down possible condition for D to become 1. D to become 1. Possible condition. First of all, we know this is O gate, no? Either of this, 1 or if both 1, you will be getting 1 here. So we'll take first condition. This is 1. Let's say this is 1. Then we don't care about this. So this to be 1, A and B, AND gate, no. A should be equal to 1, B should be equal to 1. A1, B1. C can be 0 or 1. If C is 1, here the output is 0, no problem. 0 or 1 is 1. If C is 1, then you will be getting 0 here. Doesn't matter, 1 and 0 is 1. If we get here 1 also, 1 and 1 is 1. So that is one condition. A equal 1, B equal 1, C equal 1 or 0. Then we come here. We fix this one. This is 1. This is 1. That means C need to be always equal to 0. C is equal to 0. Then only you get 1 here. No? Then we don't care about this value, whatever. So that means A is equal 1 or 0. B is equal 1 or 0. Whatever the value, whether you get 1 or 0 here it will be 1 because this is 1. Right? Now see the condition. Now it is clear, no? First we see the C is equal 0 condition is this. Then if C is equal 1, this should be the condition. And finally we can say here A is equal 0 or 1 and B is equal 0 or 1. Right? For any of these conditions, C need to be always 0 because this line need to be always 1. Then whatever the value here, you get 1 here. The next condition, AB must 1. Then only you will be getting 1 here. So then we don't care about the C. C can be 0 or 1. Right? Now it's very clear. Therefore, logic gate is very simple. We need to clearly understand and need to follow the order properly. Now see here, Q is equal AB O BC and BOC. Now first we are coming here from Q is equal AB O, right? Then soon after AB O, this is one branch, right? We can divide whatever we want, but for the easy way, once we consider we are going to divide from here, then you see the one branch is AB, the other branch should be BC BOC. Right? Now we are placing the O gate because this is O, no? We are placing the O gate here and we need AB. We need AB, correct, right? To get AB, there should be AND gate. Then A and B, AND gate. This side we need BC BOC. First you write here BC BOC, then it is very easy. Now to get BC here and BC and BOC, so you put a AND gate here. One side we should get BC, then there should be another AND gate here. Then other branch we should get BOC, then there should be a O gate. Then here you know single input, no? Then easily you can take from B and C, then A and B, all these you can use. Always when you see A, B, N, that means it's an AND gate. If you see this, always O. So when there are two digits, you know, directly you can't design the circuit. You need to go step by step till you get here single input. Right? For example, here the BC, here BC, BOC, no, not single input, no. But here you can see the BC means this side single input. Two input only make this. Right? That's how we derive. From one side you need to go. Q is equal AB, then you place the O gate here and first you divide into two parts. One side AB, one side this. then you need to realize to get this what kind of gate I should use here. Very simple, no? Here BC dot, sometimes they won't mention dot, right? Together mean a product. So B and C also product, then BC with BOC also product. So then first we have to divide from half, then one side BC we are putting another AND gate to get the BC, O gate here to get BOC. After that ABC here you can just draw these lines and accordingly you can take the input to get this output, right? Therefore 2-3 times you need to draw it. Now once you learn this, without watching this, you only take this equation and draw. Now here input PQR, output is F, but the asking is if any single input is 1, then F is 0. For any single input is 1, so that means OR gate, no? Right? If it is a OR gate, always for one single input you will be getting 1, no? So 1 or 0 1, 0 1 0, 1 or 1 1, 0 and 0 only you are getting 0. But any of the input F is equal 0 means that is not a OR gate. O and not. Why? Because we can easily see here, next hint is given, if all inputs are 0, then F is 1. All inputs are 0. In the OR gate, if all inputs are 1, you will be definitely getting 1. All inputs are 1, all inputs are 0, it will be 0. But if NOT gate is placed, you will be getting 1. So why we can't take the NAND gate? Because the NAND gate, this is not true, no? Any single input is 1, output is not 0, no? Any single input is 1, always output is 1 in NAND gate. So the NO gate, right? This is how we derive. If you can't remember, at least you can place it and see like this. Now the next they are saying A or A bar is equal 1 always. So we are not going in deep here, the De Morgan's theory and all, it is there, right? For simply they are saying A or A bar is always equal 1. Prove the statement using a logic gate circuit. They are asking to prove the statement using the logic gate circuit. Very simple. You just input A and A bar and see whether you always get 1. Right? Then this is a OR gate, no, definitely. So it's very simple. Here you take a OR gate, feed A here, the same A you are feeding here, you are putting the NOT gate, then this become A bar, no? Now you see, whatever the value you put here, 0 or 1, always you get 1 here, right? They are directly asking to implement the circuit, right? Now it is very clear, using the Boolean expression you should be able to draw the logic gate, and with certain scenario is provided, according to the scenario you should be able to write the Boolean expression, right? The same time, if logic gate is given, looking at the logic gate you should be able to derive the Boolean expression, right? So next few video clips we can see from logic gate how to derive Boolean expression and how to use logic gate to solve a practical problem. Thank you.